In this video, we're going to discuss how to find the domain symbolically of a given function and also then to confirm it with a graph. So on this problem, we're going to start with a function that's a rational function, a ratio of two polynomials. And whenever you have a rational function, you need to note that the denominator cannot equal 0, because if the denominator equals 0, then the function would be undefined. So we'll start by rewriting the denominator, x squared minus 3x minus 10, and try to first figure out where does it equal 0. And that'll be our trouble spots, or places that we want to exclude from our domain. And in this case, we have a quadratic equation, so it's most simply solved by factoring. So we're looking for multiples of negative 10, two numbers that multiply to negative 10, and add to negative 3. So those numbers, let me go ahead and set up our two factors with x's in the front spots. So the two numbers that would meet that criteria would be a positive 2 and a negative 5. Now double check that before we go on. That is, if you were to multiply these two, when you're multiplying out these two binomials, the product of the last would be positive 2 times negative 5, and that is what would give us our negative 10 in the back. And for the outside, we'd have a negative 5x, and on the inside, a positive 2x, and that's how we get our negative 3x in the middle. So it looks like we factored it correctly, so we're ready to separate this into two separate problems, because if they multiply and equal 0, then one of those factors must be 0. So either x plus 2 is 0 or x minus 5 is 0. In solving these, we just move the number to the other side, so x equals negative 2, and on this one we add 5 to both sides to move it x equals positive 5. So what we found so far are the two numbers that have to be excluded from our domain. So our domain would be all real numbers except these two numbers. So all real numbers except x equal negative 2 and 5. Now if we wanted to explicitly say all the numbers it could be in interval notation, we'd start with negative infinity, and we would go up to negative 2, but using a parenthesis, not include negative 2, and then join that, the union symbol, with all the numbers between negative 2 and 5. Again, not including negative 2 or 5. And then join that with 5 to infinity. So basically we're saying everything but jumping over negative 2 and positive 5. So now let's take a look at the graph of this function and how we see this show up in the graph. So here we are with the graph of this function, x plus 1 divided by x squared minus 3x minus 10. And we can see that at negative 2, we have a vertical asymptote. So we have a graph to the left of negative 2, then a break, then we have a graph between negative 2 and 5, another vertical asymptote at x equal 5, and then a graph also to the right of 5, greater than 5. So we have three different parts to our graph, and we notice if we were to scan this graph from left to right, scanning it left to right, we can see that we have things between negative infinity and negative 2. Then we have to jump over the negative 2. In between negative 2 and 5, jump over the 5, and then 5 to infinity.